Hello friends, how are you? Hope you are doing great. My name is Balraj, and this is the third session. I'm going to explain one by one. Previously I have explained to you that what is CVG, and the further initial steps I have guided you one by one. Now we'll go ahead with the further possession, and today we'll discuss about this that how the project execution timeline and how it starts. So without delay, let's start. So if you haven't subscribed our YouTube channel, the link is mentioned. You may go to there and you may subscribe our too for more update. If you haven't seen my previous videos, that is based upon CVG number 1, CVG number 2, and this is number 3. So you have to go on the CVG 1 and 2, then you will have to come on 3, then you will be able to understand what I was explaining, and it will be very good for you as well. So there are many owners and many investors have many doubts on the same. So today I will be clarify that doubts too. So here before going ahead, thank you for this if you are listening to. So first project is basically initiation is 1 month. So it include all topographic site survey, engineering finalization, PNID services. This is procurement planning. This is the number first phase if you go for CVG plant. Then if I come to this one, that civil work, and civil work takes after 1 month, 2 to 3 months more will take execution, and site preparation, all it will take time. So like this. So here that if you go for this one, for example, so this one, so it will take all civil work including foundation and RC 3 to 3 months. Then if you go for this structure construction, it will take maximum 4 to 5 months time, and it include all erection structure, slurry water tanks, and MS piping network too. So here it is very important, for example, if you go for this mechanical this all things are happening after the order placed, but before if you haven't placed the order, then it will be very difficult to get them all like this. Then the third phase, first this is the first phase, this is second phase, and the third phase completed where there up to 5 months, and the mechanical all that electrical work, it will take months, that is out of total 6 months. So it include all, and if you go for this for example complete all of them, so it will take 14 months time, complete 14 months time it will take. So here it is building structure, this instrumentation, commissioning, PGIR, all these activity will be the handover till 14 months time will be taken place like this. So if you need more information regarding the same, you may connect us. My number is 70095755019. So let's go ahead. So here that overview just I have explained to you that particularly if this will be the overview here, the overview CVG, that maximum Napier, if you go on Napier feedstock, or you can opt a multi feedstock too, that is depends upon you for the natural gas. And here that Napier grass basically that has which is a raw feed input, which is the size will be approx that initially that growing grass basically. So shredding, it will take 2 to 3 mm shredding, then it will be reduced up to the quantity required, that is actually the moisture will be adjusted initial before the feed, that is 12 to 12% max, that is basically native plant which will be including all recycle digester water. So 12% moisture will be reduced max, the moisture adjustment there before sending to the biodigester, that all that rest of the water will be extracted for the recycling. Slurry preparation, which is a very plays important role in the mixing tank for the biodigester, I will be explaining in the next slide. So here you can see that anaerobic digester system. Here the temperature will be maintained inside, which will be 50 to 55 degree, and the max minimum 30 days, max 15 days time will take for the anaerobic digestion. And one more thing I'm going to add here, there are unit particularly that mixing tank, pre-digester, main digester and secondary digester. So these are the number. The main digester is the 2 number, rest is all are the 1 in number. So this is the basically mixing digester RCC type, and the main digester has FRP lining, that is insulated glass wool cladding, balloon mounted will be there. This will be here. This is MS2062, and the pre-digester is of MS, that is also glass wool cladding. So here the stabilization pH, TS, VS, all HRT will be 5 to 6 days. So it will be maintained like this. So if I will check the secondary digestion, there is one nose, so it will be also the cladding, glass wool, all that insulation will be there, balloon mounter will be on it. So liquid digestion, that is a pre and post, that is a post digestion will be there, secondary digester. So whatever will be remaining, that will be covered in the secondary digester like this. So heated slurry preparation all will be doing in the mixing tank. Rest all this is very important and crucial. If you have other queries, you may ask your question anytime. I have suggested you my number too. So biogas collection and storage, it needs for example, whatever the 50% of the out of the total, that will be stored in the balloon, and it will be water sealed, and pressure release valve will be there, and gas gas light membrane are there. So this way it works. So let me go ahead with the further procession. And this further, the anaerobic digestion system, basically 50 to 55 degree temperature has to be maintained. This is the basically needed. So I have already explained this is about, for example, that initially mixing tank, then pre-digester, main digester, secondary digester, all will be in line for the procession up to maximum 40 to 50 days. So let me go ahead with without delay. So here that gas upgradation system is there, where we actually the two technology are there. One is the PSA, and second is the basically this is indigenous one, but nowadays membrane technology, where we are separating all gas basically. So H2S scrubbing, water scrubbing, BPSA system, off gas recycle loop, sludge vessel, this all we are making actually. So PSA we can do indigenously, but in case of this membrane, that will be that foreign technology to be added. Here that if I will be talking about a little bit more about it, so you can see that particularly here this one, this removable hydrogen sulfide H2S. So it is because the purity is needed basically 98%. So if 98% goes, then we have to remove H2S, which is approx 3 to 5%, and the remaining is the H2S has a carbon dioxide, which is 40% out of total, has to be removed by the BPSA, that is a pressure swing adsorption, vacuum pressure swing adsorption method. So BPSA basically that zeolite molecular sieves, where size is 3 to 5 angstrom, and we get the purity of 99%. And anaerobic system where recompressed minimum methane up to less than 3%. Here off gas recycle, for example, whatever the loss is going, that we are going into the recycle, anaerobic digestion will be sent to the biodigester. So here I will be explaining you the better way. For example, this one, for example, that if this BPSA, pressure swing adsorption, goes, then the some 3% loss will be recycled to the biodigester. And if it will not be recycled, we cannot get the purity of 99%, like this. If you have any doubts on the same, if you want to ask more, you may contact me directly. My number is 70095755019. And now without delay, let me go ahead. So here that all this BPSA and this operation pressure, all basically operating pressure will be between 0.1 to 0.2 bar for this pressure swing adsorption, vacuum pressure swing adsorption, and methane purity will be 98%. That maximum gas, as I told you, 5 TPD, that is 16,000, that is the standard, will be extracted, and 3% will be the leakage to be considered here. So, and it will be totally pneumatic, PLC and SCADA to be followed. And in case of you will be doing manual, there would be many problem, you cannot control it, the huge volume. So PLC only one person can operate. And hybrid configuration ensure that high purity suitable to SATAT is basically government organization, so allows the purity of the gas. Now here I will explain to you that bottling system, that we are multi-stage oil free, basically bottling done with the booster and all membrane technology, and this pressure PSA method. So most preferably membrane technology preferred, because of that that has a huge advantage here, but it lets it costly, so quotation will be shared next to it. So here that pressure of this PESO, as per PESO compliance, cascade pressure should be maintained up to 250 bar max. And here to manage the solid liquid output digestion, that here 2+1 will be one option, that will be solid liquid separator. So because it has a digestrate too, so solid liquid separator, we can say it is a kind of decanter which apply 24/7, and it separates solid and liquid. And solid fraction which is rich in nutrition and usable by the organisms and fertilizer too. So this is the liquid fraction actually. So let me go ahead with the further procession. So in this slide you can see that this main control panel, remote monitoring, sensor networking, SCADA interference, and predictive maintenance will be the totally 100% automation. And we have online monitoring to CH4, TS, VS, pH, and CNN, the carbon and nitrogen to be maintained, and temperature will be telling the online monitoring system. High process reliability, operational safety will be monitored through the computer. Thank you very much. Now in the next session I will be explaining the cost wise separation one by one, so stay connected. This is the version 3rd. 4th version will be totally based upon that what is the total breakup price for the EPC 5 TPD. Thank you very much, and if you haven't subscribed yet, please share, subscribe, and like. We have entertainment, knowledge, and science content too, you can watch it too. Thank you very much.